Greetings, wonderful physics students. I'm making this video to help you out with number 4 here in your Unit 2 homework. So let's see, we got 3 capacitors connected to a 1.5 volt battery. So in this picture, right, so this is representing our battery. The red terminal is representing the positive terminal of the battery, the short black one here, the negative terminal. Sometimes in pictures, like in another textbook, you'll see like a double doohickey, same picture. Okay, the EMF is 1.5 volts. Now again, EMF stands for electromotive force. That is typically also referred to as the open circuit voltage of the battery. So basically, what does that mean? The potential difference between the red and black in this picture is the 1.5 volts. And then we've got a bunch of capacitors, C1, 2, and 3. See, they're a little hard to see in this picture, but they are hooked up in series. So when the switch is closed, right, we're going to get a charge transfer. I like to think of it like this. The positive terminal here attracts electrons. So what that's going to do is it's going to pull electrons in that direction. And over here, this terminal is going to push electrons in this direction. And what you're going to get now is I like to think of it as a charge shift, because this has to occur everywhere through these wires. That's going to give us a minus plus, minus plus, minus plus configuration. Now, this is a series circuit. So these 3 charges, or let me back up. These capacitors are now said to be carrying a charge. Now, technically, the net charge on the capacitor hasn't changed. But when we talk about the charge on the capacitor, we're talking about a charge imbalance. This is what we're talking about. That's what we mean by a charged capacitor. And it's very important, fundamental to realize at this point that those charges would have to be the same, right? Because of the way a series circuit works. So if I put like a barrier here, 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 and here, 4 barriers, when that charge shifts, if you will, the same amount of electrons is going to have to move past each one of these barriers. Right? And that's why those charges are going to end up being the same. Now, these are in series, so you calculate what's called an equivalent capacitance. Right? You find C equivalent. Then you redraw the circuit. Always, always, always redraw your circuit. And your circuit now is going to look like this. You're going to replace the 3 in series with a single equivalent capacitor. Once you do that, you should be able to calculate the charge on that capacitor. Now, it's kind of a fundamental question. How does that relate to the picture? Well, I like to think of it like this. This plate right here, like literally means like this one. And I'll do a different color here. And then this plate literally means like this one. So basically you'll know the plus Q and minus Q here and here. And then you basically know the charges here and here. And that should tell you what the charge is here. I don't want to spill all the beans here, but that should tell you this. Basically, you've calculated 3 things at this point. Now, it also says, by the way, to find, let's see, the charge on each and the potential difference. So capacitance, right, is defined as charge over voltage. Or I'll think of this in equation form, right? Capacitance is equal to charge over voltage, right? This is how it's defined, charge per unit voltage, but equation-wise, that's what that means. So if you have any 2 of the 3, you should be able to calculate the third. So to get the voltages, all you need is the capacitance on each capacitor and its charge. And your capacitances are sitting right there. So you should have no trouble getting that done. Let's see, repeat the problem assuming a wire is placed there as shown. All right, so now when we close the switch, I should have did that in the previous problem, but when the switch is closed, there's something we need to realize here. And again, I should have did this in the previous problem. This is all conducting material. Right? So I am color coding a potential. You'll see me do this in a lot of circuits. This is all one potential because it's conducting to there and to there. And that should tell you what the voltage and charge is across that capacitor. Then you just repeat the problem. I'll just say move on with the problem from there. That should get you through that. If you're having trouble, come find me and I'll help you out. Hope that this helps.